Hey guys, so in this video we're going to talk about two different types of chemical reactions. Okay, the two that we're going to talk about in this video are endothermic reactions and exothermic reactions. And I'm going to go ahead, I'm going to write those on the board. And we'll start with exothermic. All right, so exothermic reaction, endothermic reaction. And really what an exothermic reaction is, it's just a chemical reaction where chemical reaction that produces heat. All right. So when we have a exothermic reaction, there's going to be a lot of heat involved. Okay, and the example that I'm going to give you guys here, real quick, is going to involve hydrochloric acid again. And I'm going to go ahead, I'm going to pour some into a beaker. Got to be glass. It's got to be glass. All right. And I'm going to go ahead and into this beaker, I'm also going to throw in some aluminum. All right. So it's going to take a second to go because the aluminum foil has some oxygen on the outside, but this hydrochloric acid is room temperature, and I'm going to go ahead, I'm going to get a measure real quick of its temperature in Celsius, and it looks like we're staying right at about 20 degrees Celsius. 20 degrees Celsius for this guy. All right. And unfortunately, this takes a minute to get going here. So just remember our starting point was 20 degrees Celsius. As this starts going, because I'm starting to notice some bubbling here. As it starts going, we should expect that temperature to rise pretty dramatically. And I'll be able to feel it with my hands as it starts going, but you guys don't have the luxury of that, seeing that you guys are on a video. So you won't be able to feel it, but you can take my word for it as I show you the temperature change as we go. All right, I'm starting to notice some bubbling here. You can hear some crackling. And I'm just going to be quiet. I'm going to get that smoke out of here because it stinks. It's nasty. This is kind of like the genie in a bottle, right, where a lot of smoke was made. Okay, and it's starting to calm down now, all right? But when I touch that glass, holy smokes, is that hot, all right? Yikes. And when you look into this, you can see that the aluminum foil is just completely deteriorated, right? It's just not even there. But I'm going to go ahead and let's see if we can get a temperature here. Okay, it is climbing. Holy smokes, we're at 40 degrees Celsius. We're at about 48, 49, 50 degrees Celsius. So we more than doubled our temperature. It looks like it's still climbing a bit. 52. It looks like we're staying there. All right. So with our exothermic reaction, we added about 30 degrees Celsius. So you can imagine how hot that is. Okay, we doubled the temperature. Yeah, really hot. So if there is an exothermic reaction, we can be sure that there is a endothermic reaction. Okay, so there's a reaction that makes things hot. We also have a reaction that makes things cold, and that's endothermic reaction. All right, and like I just said, endothermic reactions, these are chemical reactions. Chemical reaction that produces, I'll just say, a drop in temperature. Produces a drop in temperature. Sometimes the temperature drop is, not as noticeable. Okay, it's kind of a small temperature drop, a few degrees Celsius. But sometimes our temperature drop is pretty substantial. So we're going to go ahead and do that. So give me a second to get the necessary materials. I'm going to get something smaller here. Okay. I have a small beaker right here, and there's two things that I'm going to be mixing in this reaction. Okay. We have something called, sorry, it's all clumped up. We have something called barium hydroxide. Right? And I'm going to go ahead, I'm going to get some scoops of this. Get some scoops out. And really it just comes to kind of, well, I guess I'll pour it in. You can see it comes out in little crystals. Alright, kind of like little flakes. Yeah, just like that. Looks like little ice cubes, kind of. But it is a solid. Okay, sometimes when we're dealing with chemicals, they're liquids, but this one happens to be a solid. I'm going to set this aside. Alright, and we're also going to use something called ammonium chloride. Okay, and this is more like looks more like a salt. Alright, and I'm going to add that, but before I go ahead and do that, I'm going to take a little piece of wood, and on that wood, I'm going to put some water. Okay, I'll make it more visible and see you guys in a second. Okay, wooden ruler, and this is an endothermic reaction, but to just give you an idea, because I'm not going to do a temperature check before and after, you're going to see a change, you're going to see something happen that's just going to show you how cold this reaction actually is, all right? So here we are mixing two solids together, and I'm going to put a bunch of scoops in here. And we're going to start to notice quite a few things happening here. Okay, so I'm setting it on the ruler where there was water. Keep there. Then I'm just going to start stirring this guy up. Okay, so I'm mixing two solids. Okay, two solids, and we're going to see something that just doesn't seem possible. All right, but it's going to take a second. Sometimes with science we have to be patient, right? Kind of grounding this guy up. And as I'm doing this, I feel the beaker getting cold. Okay, and you might not believe me, but I'm sure you will in a second. Keep mixing this up. Yeah, this beaker's really getting cold now. And what's always crazy to me is we have two solids that are chemically reacting with each other. Two solids are doing that. And you saw that I didn't add any liquids in here. It was just all solids. But what I'm starting to notice, and you might be able to see as well, is this is becoming a liquid. Alright? So in this case, we mix two solids together, and we end up with a liquid. Now you can hear it now, right? It really sounds like a liquid. Should have wore gloves, guys. Should have wore gloves. I want to see if I can kind of put my camera up here just to show you how this is a liquid. Let me see if I can lift it up here. I don't know if you guys can tell. It's just liquidy. You might be able to, might not be able to. Okay, I'm gonna go ahead and try something here. I think we're set. And if it doesn't do it, I'm sorry. but I think it should. Okay, I'm gonna go ahead. I'm gonna lift this up, and look at that. It got so cold that the ruler, okay, remember there was water on the ruler, it actually froze to the beaker. And let me see if I can angle this up here for you guys. Look at that. It's all just the liquid right in there. All liquid. And actually, I have a really weak sense of smell, if any, but this smells really bad. Okay, and I just peeled it off. But that is our endothermic reaction because temperature dropped quite a bit, but that's a dramatic one there. All right, awesome. Endothermic reactions, exothermic reactions. Thanks, guys.